complete protein synthesis, we need to undergo translation process that consists of 3 steps. First is initiation, next elongation, and lastly termination. Now we go with translation component. The first component is tRNA, large ribosomal subunit, small ribosomal subunit, and lastly mRNA sequence. Initiation of translation usually involves the interaction of certain key protein with a special tag bound to the 5' of an mRNA molecule, the 5' as well as with the 5' UTR. The small ribosomal subunit bind to the initiator amino acid methionine. This complex then attached to the cap structure at the 5' of an mRNA and scan for the start codon AUG. The process is mediated by several initiation factors. The large ribosomal subunit joins the complex and all initiation factors are released. The ribosome has 3 sites. The A site is the entry site for tRNA charged with amino acid. The P site is occupied by peptidyl tRNA, the tRNA that carries the guanine polypeptide chain. The E site is the exit site for the tRNA after it's done delivering the amino acid. The initiation tRNA is positioned in the P site. Next is elongation. Elongation depends on eukaryotic elongation factors. At the end of the initiation step, the mRNA is positioned so that the next codon can be translated during the elongation stage of protein synthesis. A new tRNA carrying an amino acid enters the A site of the ribosome. On the ribosome, the anticodon of the incoming tRNA is meshed against the mRNA codon positioned in the A site. When the right amino acyl tRNA enters the A site, a peptide bond is made between the 2 now adjacent amino acids. As the peptide bond is formed, the tRNA in the P site releases the amino acid onto the tRNA in the A site and become empty. At the same time, the ribosome moves 1 triplet forward on the mRNA. As a result, the empty tRNA is now in the E site and the peptidyl tRNA is in the P site. The A site now is unoccupied and ready to accept a new tRNA. The cycle is repeated for each codon on the mRNA. Termination of elongations depends on eukaryotic release factor 2. The process is almost similar to prokaryotic termination, but unlike prokaryotic termination, there is a universal release factor ERF1 that recognizes all 3 stop codons. Termination happens when one of the 3 stop codons is positioned in the A site. No tRNA can fit in the A site at that point, as no tRNA that can match the sequence. Instead, these codons are recognized by a protein, a release factor. Binding of release factor catalyzes the cleavage of the bond between polypeptide and the tRNA.